Alrighty, welcome everyone to day 5 of Advent to Code. I have my base code all set up and ready here. There is now only 17 seconds until today's question and puzzle are released. So without further ado, 10 seconds. Fingers crossed. Hopefully today's isn't too bad. We actually made good progress yesterday on our placement. We got to almost top 200, so I'm pretty impressed with myself. But anyways, question 5 for today. What do we have? As the page slowly loads up. Take a second. There we go. You board your plane only to discover a new problem. You dropped your boarding pass. You're unsure which seat is yours, and all of the flight attendants are busy with the flood of people that are suddenly made to the passport control. You write a quick program to use your phone's camera to scan all of the nearby boarding passes, your puzzle inputs. Perhaps you can find your seat through the process of elimination. Instead of zone or groups, this airline uses binary space partitioning to seat people. A seat might be specified like that, which means front, B means back, L means left, right means R means right. The first 7 characters will either be F or B. These specify exactly one of the 128 rows on the plane, 0 through 127. Each letter tells you exactly which half of the region the given seat is in. Start with the whole list of rows. The first letter indicates whether the seat is in the front or back. The next letter indicates half of the region seat is in until you're left with exactly one row. So this is literally a binary search algorithm just in a string version. Interesting. Okay, so this kind of just gives you some examples. The last 3 characters will be the left or right. They specify exactly one of the 8 columns of the seats on the plane. The same process for the above. Okay, so is this just straight up binary? Because if it's, I'm gonna do a quick binary to decimal conversion. So if F means the lower half, so F is gonna be a 0, B is a 1, 0, 1, 1, 0, 0. Is this 44? It is 44. We can just try to convert this to binary. Okay, because it's a binary search. So our puzzle inputs, okay. So I haven't read the full question yet, but let's post this in. So what we're going to do is we're just going to take each line, convert it into binary, and do a binary conversion from the binary number into a regular number. So we are going to do a for loop here for string s in inputs. We are going to do s dot, we're going to track our int, we're going to track our integer, this is going to be our number, it's going to start at 0, so this is going to be binary, so we're going to have to start our power at the highest. So in this case, so it's going to be 0, 1, 2, 3, 4, 5, 6. So power is going to be 6, and then we're going to have to go int I equals 0 while I is less than 6, I plus plus. Okay, so we're going to go through each character in here. So it's going to be s char at I, and we're going to do a quick check if the char at I is a B, which is going to be a 1. We will go ahead and do number plus equals math.pow of 2 to the power. This is a very simple binary conversion. Basically, if you don't know binary, it's the position is 2 to the whatever. Binary is from right to left reading. So, but because we're reading the string right to left, we have to kind of flip it around to where we're starting with the largest power on the left side and reading across. So that's why power here is starting at a high number. Alternatively, I could just do I minus, or a 6 minus I, but it's actually, that's be a better way because I'm not decrementing power. So we're just going to do 6 minus I here. Okay, so now there's our number going up, and then after this, we now have our seat in binary. So, look through your list of boarding passes. What is the highest seat ID on a boarding pass? So that's those. So now all that's left is to do the right whatever. Every seed is also use seek ID, multiply the row by 8 and then the column. Okay. Alright, so now we have the row that they're sitting in. Now we need the specific seat in that, which is the column. So in this case, it's the last 3, so we're going to have to do one more for loop. So this is actually going to be row, not number. And then we're going to need one more for loop, giving us the column here, if I can type 0, and then we're going to do for int I is going to be equal to 6 starting, while I is less than 9, I plus plus. Again, same exact thing, just flipped around. And in this case, which one is a 1? Right is the upper half, so an R is 1. And so this will be then column, and this is actually going to be 3. Ooh, not 3, it's going to be 9 minus I. Because again, we're parsing the string. It's a little bit weird, but at any rate. All right, so there's our row and column. So in this case, we need an int max here. It's going to be starting at 0. We're going to need an int row column. Let's call it row column, easy enough. And it is the row times 8 plus column. There's our row column, and all we gotta do is check here is if row column is greater than max. If it is, max equals row column. And last but not least, just do a system out print line of our max. Go ahead and run this. 918 submits that. Ooh, it's not right. Interesting. Okay. I might have messed this up though. No, it's not. Ooh. Hang on. All right, let's try to throw one through that we know is valid. So this one is example here. So let me just throw this through. So I'm actually going to set inputs equals collections. So this should give us 44 if I'm right, which it does not. Gives us, oh, we're 1 off. Could I just add 1 to this? I wonder if I'm just 1 off somewhere and I'm just missing it. Let's do that. So we get 919 now. Maybe? Hey, I was just 1 off somewhere. I don't know where, but at any rate, there we go. All right, on to part 2. Ding, the fastener seatbelt signs have turned on. Time to find your seat. It's completely full flight, so your seat should be the only missing boarding pass on your list. However, there's a catch. Some of the seats at the very front of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back, though. The seats with IDs +1 and -1 from yours will be in your list. Okay, so we need to find the ID of our seat. Okay, so we need to go through all of these and we need to sort and then figure out where our seat is in this. So your seat should be the only missing boarding pass in your list. Okay, so let's just do, instead of a max here, we'll keep it. But let's just do a list of integers. This is gonna be called IDs. And what we're gonna do here is we're also going to just stuff in IDs the row column. And at the very end here, after we get max, we're going to just do a for loop on int I in IDs. We're gonna keep track of the last ID, and we're just gonna go through. We're gonna try and find a case where we get the one before it is the one before it and the one after it are one apart. Yeah, so we're gonna have to do if last ID does not equal -1 and I minus last ID equals 1. I'm just going to system out this. I don't know if this is correct. I just want to get a sense of where we're at with this. So we're going to output I minus 1. Actually, this should be off by 2. Sorry, it's going to be off by 2. And then we're going to update last ID to be equal to I. I just want to get a sense of where this is at. So let me see what this gives us. It gives us 2 possible. It's going to give us 660 and 562. Hmm. 660 came first, which is kind of odd. Oh, we didn't sort this. Oh, sorry. We didn't sort the IDs. We need to do IDs, sort integer compare to. That's what I'm missing. That way now these are sorted into correct order. That way they're all in linear form, I guess. Sorry, this isn't returning anything. It's just that. Let's try this again. And now we get a bunch. Oof. Well. Okay, let me do this. Let me just output every single ID and let me get a sense of what these IDs look like. Because again, I'm trying to figure out what this is meaning off the top of my head. We're getting a bunch of 919. We're getting a bunch of duplicates, which is not what I would have thought. What's going on here? So you should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and the back of the plane don't exist on this aircraft. They'll be missing. The seat IDs, the seat with IDs +1, -1 from yours will be in the list. Well. So yeah, this happens a few places, and these IDs are not... Well, this is interesting. Because, yeah, these are not what I thought this would be. So we have the max, which is 919. Fine. I don't know if I got lucky with that somehow. But why am I getting a bunch of duplicates? I feel like one of these is not correctly done. My binary must be off somehow. This should be a 5, not a 6. And this should be an 8. I still get 919. I do not. Because in theory, this is 1, 2, 3, 4, 5, 6, 7. Oh, wait, am I missing? Oh, I didn't go far enough. How did I get this one right? And then this one would be from 7, 79. Oh, that's okay. So my code was wrong somehow, but yeah, I got the question right. Interesting. Did that fix? Sorry, this is messed up. 6 is right. Because it should be 0, 1, 2, 3, 4, 5, 6. Right? Or not? No. I'll get this eventually here. Alright, I'll probably take a... I may debug this for a second and I'll take a quick jump cut here. Okay, so I figured the issue. My issue was I was going from 7 to 9 here. This is 7 to 10 because this needs to be from 7, 8, and 9, the last 3 digits, or the last 3 numbers in our string. That was the issue. How this worked in the first place, or how I got the right or how I got the right answer in the first place, is beyond me. I think I just got extremely lucky. But at any rate, this has been fixed. So now what we can do is we can re-implement this code here, because now these are incrementing correctly, and I don't need output here. So now we should get only 2 numbers, 642 as our answer. Submit it. There we go. Oh, I want to see. Yeah, we did really good on the first one, then we tanked the second one because I messed up the first one. Alright, so good job, me. Okay, let's recap the questionnaire and my solution, and let's actually explain how it's meant to be done here and not with broken code. So the input for today is a bunch of numbers here. We are trying to find our seat on the plane. The first one is asking just a sanity check to figure out what the largest seat in the plane is given the boarding passes. These boarding passes are given in a kind of binary search algorithm style system, but that means that we can convert this system of letters into a binary number. So in the case of B and F's, B is going to be a 1 because it's the back half, so it is going to be from, in this case, it is going to be a 0 in the 5 power, or a 6 power here, whichever one it is, which is going to determine whether or not it is 0 to, what was it, 0 to 120 something. If I go back further enough to the question, it's going to determine whether or not it is 0 to 127 or 128 to the end, and basically the rest of them are just determining where that is by converting these to a binary number. Same with the row and column. So once you can take this and convert it into a binary number, or a ones and zeros in effect, we can just use binary math to get that number into an integer and then into the form they want, which is the row times 8 added to the column. And then from there finding the max for part 1, and then part 2 is just collecting these all into an array, sorting them to be in order, and then finding the location where we get a jump from one ID, skipping over 1, and then to the other ID, which is basically skipping a seat, which is then for our seat. So again, I have no idea how I did this first part correctly, given my code was incorrect. I somehow just got lucky, I don't know. I mean, I guess it's binary because I was off on the ones on the binary. I guess I kind of got lucky that I was off on the ones and that I was off on the correct one. Or I guess I got unlucky because I could have been not off because it could have been a 0 instead of 1 in the ones place. At any rate, the key for today is knowing binary, knowing how binary works, knowing how you can go from a strings of ones and zeros to a decimal number. If you're not familiar with that, read up on what binary is, but beyond that, it's pretty easy, just knowing that in this case we have to read from left to right instead of right to left, which is how binary typically is written out. But at any rate, again, I've rambled for probably long enough, so hopefully you guys have enjoyed today. We'll see you guys all for tomorrow for day 6. Peace out.